Assalamualaikum and hi to everyone. Thanks for watching this video. So in this video, we continue on the revision part 2. Encode the bit pattern for the given stream of bit with the PS key. So now you have a phase shift keying. So it will change on the phase. Okay, we have 1 here. So at 1, it look like this one. Phase 1 and then it start with 0. So it start with 0. And then 1 start with number 1, 0 start with 0, and then 0 again start with 0 again, and then number 1 start with 1, start with 1, 1 again, and then 0, so start with 0, and then 1. So this one for the PSK, phase shift keying. Okay, the next part is for the FSK, frequency shift keying. So under the FSK, okay, for 1 it look like this one. For 0, the frequency is more. Okay, and then 1, and then 0 again, 0 again, and then 1, 1, 1, 0 again. Okay, you can refer to the lecture note or the reference book for the better drawing compare to my drawing. Okay, so that's all for the encoding part. So you should know how to draw the pattern of the digital encoding, okay, based on the bit of stream that have been given to you. Okay. Okay, next question number 6. List 3 advantages of the twisted pair cable. So this one is under topic transmission medium. So under topic transmission medium, we have unguided and we have the guided. So you should know what is the guided. Guided, we have the twisted pair cable, we have the coaxial cable, we have the fiber optic cable. And then at the unguided, we have microwave, radio wave. You should able to differentiate between the unguided, the guided, and type of guided as well as type of the unguided. So based on this question, it just asks the advantages. What are the benefits of the twisted pair cable? Okay, the UTP cable. What is the benefit of using that kind of cable? So you should list out 3. Okay. First, it can pass wide range of the frequency. Cost is quite cheaper compared to the coaxial cable and the fiber optic cable. Twisting make it probable, and both wires are equally affected by the external influence noise. Okay, because we twist the cable, and then attenuation is lower than the coaxial cable. So these are the advantages when we use the twisted pair cable. Okay, next question, you need to complete the table. So you are given a table of the cable. We have coaxial, twisted pair, and fiber optic. So you need to complete it. Okay, maximum distance. Okay, we have different cable have different distance. So if you want to create a network with longest or largest area, so you need to know which kind of cable that you should use. So now we have this maximum distance. Okay, connector, type of connector. Coaxial, we use BNC. Twisted pair, we have RJ45, and then fiber optic, we have using the MTRJ. The name is connector that connect your cable, and then we have the performance. This one higher bandwidth than the twisted pair cable. This one can increase the attenuation. Okay, this one higher bandwidth than the coaxial cable. Okay, in terms of the performance, this one in terms of the application, coaxial cable for the analog telephone network, OTV network. Okay, and then this one used for the backbone network. It is more on the characteristic of the cable that we have. Okay, next question. Explain two factors that involve in choosing between the fiber optic cable and compared to the copper wire. So fiber optics is the optical cable. Cable, copper wire is more on twisted cable. So there's a lot of factors. The question asks two factors. Okay, you can go for the speed, security, or data delivery, and then explain what is speed. In terms of the speed, fiber optic can transfer the data faster compared to the copper wire. In terms of the security, which one is more secure for your data when they transmitted from one side to another side? And then in terms of data delivery, it's referred to the speeds. It's referred to the accuracy. Okay. Okay, so you should explain about the speed or the security part or the data delivery part. And for question number B, what is the purpose of cladding in optical fiber? Okay, look back on the optical cable structure, and then there is one part that we call as the cladding. The purpose of this cladding is to reflect, for the reflecting part. Okay, so a light beam traveling through the core is reflected at the boundary between the core and the cladding. So if the incident angle is more than the critical angle. Okay, you should know what is the incident angle and what is the critical angle. Okay, the purpose is to reflect, because the signal is in the optical signal, so we need the reflecting mechanism in order to transmit the signal in optical fiber. Okay, next question number 7. Okay, there are two types of fibers propagation mode. We have single mode and we have multi mode. Okay, the question asks which type is better and explain. Give two reasons why the mode that you choose is better. Okay. So the better propagation mode is a single mode. Okay. So these single mode cable are designed to carry light directly down to the fiber. Okay, you can refer to the diagram of the multi-mode and single mode in order to imagine or visualize what the things here about my explanation. Okay, single mode cable are designed to carry light directly down to the fiber, and the single mode give a higher transmission and up to 50 times more distant than the multi mode. The core from a single mode cable is smaller than one from a multi mode, and this one you can refer to the diagram. And single mode is vital part of broadband network. So it's more faster when they transmit the data. Okay, next question is differentiate between omnidirectional and unidirectional wave. Give type of transmission that use of each wave. Okay, omnidirectional means from multiple direction, and unidirectional is only for one directional. Okay, so you need to explain what is omnidirectional. So in omnidirectional, it propagated in all directions. So its sending and receiving antenna do not have to be aligned, and then it can penetrate the wall. For unidirectional, it's propagated in one direction. Sending and receiving antenna need to be aligned. Okay, you can refer to the antenna for the unidirectional and omnidirectional. Identify the difference between those antenna, the characteristic of those antenna. Okay, then radio wave transmission use the omnidirectional propagation. Okay, this one give type of transmission, the use of each wave. Example here. Another one is microwave, radio wave for the omnidirectional, microwave for the unidirectional propagation. So this one is the example. Okay, next question, part C. Part C is quite tough question, quite difficult. Okay, question number 1, explain how the Manchester encoding overcome the limitation of NRZL. So you need to explain, you should know what is the Manchester and you should know what is the NRZL. Okay, the suggestion answer here for NRZL encoding, it given a long string of ones or zero, there is no transition. Okay, which means that, okay, let's say you have a bit stream of 1 and 0, means that there is no transition. So that means the receiver must rely on time alone in order to determine where the bits begins or end. Example, by looking at the clock. If our clock does not run at precisely the same rate as the transmitter clock, means the receiver clock and the transmitter clock is not the same, then we may misinterpret the signal and lose the synchronization with the transmitter because our clock is not in the same rate. So if the level of the signal change, this one we call as transition of the signal, then there is an event that we can recognize and use to resynchronize ourselves. Okay. Manchester encoding solve this problem by ensuring that there is a transition in the middle of every bit. Thus, for any sequence of bits, we are guaranteed to have transition that can be recognized and thus can be used to synchronize with the transmitter in every bit interval. Okay, based on this point, first you need to explain about the drawback of the NRZ. So the key point here is about the no transition. So we need to look at the clock, but how about if the transmitter and the receiver clock are not in the same rate? So it will misinterpret and lose the synchronization with the transmitter. So what the Manchester do? Okay, Manchester encoding solve the problem by ensuring that there is a transition in the middle for every bits, even we have a long string of 1 or a long string of 0. So these help in order to resynchronize or synchronize the signal when we transmit the signal. Okay. Okay, next point is about the DC component. Okay, the DC component is the component of the signal with a frequency of 0. Okay, frequency of 0 means we have a straight line. So you can also think that the DC component as a vertical shift in the time domain graph of the signal. Okay, just a vertical line. So we can determine if a signal has a DC component by calculating its average value over time. If its average value is 0, then the signal has no DC component. So in the case of NRZL, there are possible sequence of bits 100, 100, 100, and continue 100 again. So which is have an average value that clearly not 0, and thus the NRZL has a DC component. Okay, this one it talk about the DC component in the NRZL. So in Manchester encoding, the value of the signal in each bit interval occupy both polarities. So it spends half of its time at the negative polarity and half of its time at the positive polarity. You can check back on the Manchester encoding part. So thus the average value of the Manchester encoding over any bits interval regardless of the bit value an interval represents is 0. Okay, so thus Manchester encoding does not have the DC component. So at this point is the elaboration and the explanation about the DC component that may occur in the NRZL. And when we use the Manchester encoding, we can eliminate that issues because there is no DC component under the Manchester encoding. Okay. Okay, the last part, question number 2. For A, find the difference between the synchronous and statistical EDM. So you just explain what is the synchronous and the TDM and how and differentiate both. Okay, so in synchronous TDM, the multiplexer allocates exactly the same time slot to each device or each channel resources at all time. Let's say we have 4 channels, so the multiplexer will allocate 4 slot for every channel. Okay. However, in the statistical TDM, the number of time slot are based on the statistical analysis of the number input line. So it refers to the input resources. If there is a data, then it will allocate for that channel. Otherwise, it will not allocate for that channel. Okay, and lastly, describe 2 techniques of data rate management. Okay, we have multiple techniques, but this question only asks about 2 techniques. So, one of the technique multi-level multiplexing, and then you need to discuss and elaborate what is the multi-level multiplexing. Give the example, or you may use the figure in order to explain. Okay, another one is fast stuffing multiplexing. Okay, you need to elaborate, for example, multi-level multiplexing. So this technique is used when the data rate of an input line is a multiple of others. And then you give the example. Okay, because the mark is 4, you need to explain and give example. Another part, pulse stuffing, explain and give the example for this technique, pulse stuffing. So that's all. So hopefully everyone able to answer the question for our next test. So any question you can ask me through the Telegram. Thank you and Assalamualaikum.